Hi, my name's Mike Knott. This is a presentation on ozone pollution and population density in the state of Maryland. It's a final project for MSF A 580 Industrial Hygiene. So the introduction, this presentation is going to focus on ozone pollution, specifically in the state of Maryland. And ozone is a naturally occurring gas that is the most abundant in the troposphere of the Earth. And it's present in much smaller amounts at ground level. In the troposphere, ozone serves a very important beneficial role as it absorbs the sun's UV radiation. However, at ground level, ozone isn't as beneficial as it can cause adverse health problems with humans. It can have negative effects on people's circulatory, cardiovascular, and respiratory system. And most of the negative effects are isolated to the respiratory system. And there's certain populations that are more susceptible to ozone exposure than others. Small children, the elderly, people with asthma or other respiratory diseases, and people who are active outdoors are all more susceptible to ozone than others. And for the state that I was evaluating, I chose Maryland. I'm from the state of Maryland, and I grew up there. And in 2013, Maryland had the highest mortality rate in the U.S. Due to air pollution. It was reported that a total of 113 people per 100,000 died as a direct result of air pollution. And also, Maryland is the ninth smallest state in the country. However, it's the 19th most populated state in the country. So the population density in Maryland is pretty high compared to other states in the country. So given that Maryland has a high mortality rate due to air pollution, it kind of raised the question for me, does population density impact the concentration of ozone specifically in the state of Maryland? And it's important to note that there are definitely other possible sources of air pollution, such as particulates, sulfur dioxide, carbon monoxide, stuff like that. But for the purpose of this report, we're just focusing on ozone. So the methods that you use to determine whether or not population density impacted ozone concentrations was that I downloaded the data from the Environmental Protection Agency, the EPA. I went to their website and I downloaded their daily data for specifically ozone. And there are a total of 22 different air quality measurement stations located in the state. And the data was downloaded for 5 years, starting in 2018, going back to 2014. Once the data was downloaded, the annual geometric mean and peak concentrations were calculated for the data set. And another thing that it did was look at the distribution of the air quality stations throughout the state. It's important to note that Maryland's broken up into 5 regions. You have Western Maryland, on the western side of the state. You have the capital region of Maryland, which includes the areas around Washington, D.C., and then go north. And then you also have southern Maryland. You have central Maryland, which includes Baltimore City, Baltimore County, and then you have the Eastern Shore. The Eastern Shore of Maryland includes all of the counties east of the Chesapeake Bay. This map here shows the 22 monitoring stations that were found in the state of Maryland. And as you can see, there's a pretty good distribution. You have Piney Run, which is in Western Maryland, in Hagerstown. You have some stations in the capital region, a lot of stations in the central region of Maryland. You have a couple in southern Maryland and a couple on the eastern shore of Maryland. So there is pretty good distribution throughout the state. Once I started diving into the data, it became pretty clear up front that not all of the stations reported data throughout the year. There wasn't a single station that reported ozone concentration data for every day of the year. So the average data reported was only 240 days. And what I found is a vast majority of the stations left out the winter months of ozone concentration. So what I wanted to look at was whether or not that potentially impacted the data. And what I did is I went into one of the reporting stations that recorded the most amount of data, and I plotted the annual um, the concentrations throughout the year. And what I found is that the ozone concentrations are sinusoidal in nature, in that the concentrations are highest in the summer and they're lowest in the winter. But since I was using geometric mean to evaluate the data, I could only use stations that reported over 90% of data throughout the year. Because if we used all of the stations, then we would get artificially high geometric means. By leaving out the winter months of December, January, February, and March, the data set would be artificially high because those months represent the lowest ozone concentrations throughout the year. So any station that didn't report data for more than 90%, they couldn't really use because the ozone concentrations for geometric mean wouldn't be realistic. So that being said, there was only 6 reporting stations that had over a 90% reporting rate. And those stations are found on this map here. And fortunately, one of those stations was in Western Maryland, and 2 of those stations were on the eastern shore of Maryland. Unfortunately, Southern Maryland wasn't captured in the data set, and then the capital region of Maryland also is kind of missing in this area. But fortunately, Essex, which is a suburb of Baltimore City, that was captured, and a couple of reporting stations in Beltsville reported data. So as far as evaluating population density, the data set is still, fairly good, considering that we have Western Maryland represented, which is a very rural area, and then you have the Eastern Shore of Maryland, which is rural as well. And then Essex and Beltsville, they're in the more urban, high populated areas. So once they isolated the data to reporting stations that were over 90%, it calculated the geometric mean for the annual concentrations for each of those stations, the population densities for the counties in which the air monitoring stations were located was calculated, and the mean concentrations were compared to the population density. Another thing that I did was I calculated the peak ozone concentrations for each of those stations, and those concentrations were compared to the ACGIH threshold limits for ozone. And those threshold limits are listed here. And it's important to note that those limits vary depending on the level of work that a person's doing. The threshold is a 0.05 parts per million for somebody doing heavy work, and it's as low as 0.10 parts per million for somebody doing light work. So for the results, what I found was that the highest mean ozone concentrations were measured in Piney Run. If you remember on that map, Piney Run is the monitoring station located in Western Maryland. And that's in a relatively rural area, as you can see on this table here. Piney Run has a low population density compared to Beltsville and Essex. But 4 of the top 5 highest annual mean concentrations were measured at Piney Run. And what I also found is that the lowest mean ozone concentrations are measured in Beltsville and Essex. And as you look over here, Beltsville has the highest population density as it's located in Prince George's County, and then Essex has a higher population density, over 10 times that of those located on the Eastern Shore. And but both Beltsville and Essex represented the lowest annual mean ozone concentrations that I found. And that can be seen on this figure here. This is a plot that shows the geometric mean ozone concentrations measured for each station for each year throughout the state. Down here at the bottom, the stations are organized from west to east in the state. So Piney Run is in western Maryland, and then the Blackwater National Wildlife Refuge is on the eastern shore of Maryland. So you have more rural on the left side of the plot, and then you have more rural on the right side of the plot, and then the higher populated areas are in the center. And what you see is there's an actual dip in the data here at the center of the plot, with an exception to Essex in 2016. But again, this is just kind of showing that the higher geometric mean ozone concentrations were found in the more rural areas compared to the urban. When we looked at the highest peak ozone concentrations, what we found is that the highest levels were measured in the more urban areas. So the urban areas of like Essex and Beltsville, they were 4 of the top 5 highest peak ozone concentrations measured. Essex was the highest in 2016, and that was measured at 0.099 parts per million. As you could see again on the population density table, Essex and Beltsville are significantly higher population density areas compared to the western Maryland and Piney Run and the eastern shore of Horn Point and Blackwater. We're going to show a plot on the next slide, but as we talk about that, just remember the TLVs for the ACGIH threshold limits for ozone. All stations reported limits in excess of the TLV for heavy work for every year reported. So there were peak ozone concentration levels measured at every station in the state that exceeded the TLV for heavy work. And there were 7 stations that recorded TLVs that exceeded the TLV for moderate work. And although it didn't meet or necessarily exceed the TLV, it's important to note that Essex in 2016 recorded a concentration of 0.099. That is very close to the TLV for light work. So, what this table shows, again, this is organized from west to east. The higher ozone concentrations, at least the higher peak ozone concentrations, were found in Beltsville and Essex. There are a couple that were recorded in Horn Point and Blackwater, but the higher magnitudes are definitely in Beltsville and Essex. So in conclusion, when comparing ozone concentration to population densities, the data was a little conflicting. The annual mean ozone concentration was higher in the lower populated areas. However, the peak ozone concentrations were higher in the higher population density areas. So it really depended on what metric you were looking at. Because if you're looking at mean, lower populated areas were worse. And if you're looking at peak, higher populated areas were worse. But one thing that was important to note is that all stations exceeded the ACGIH TLV ozone exposure limit for heavy work. And there were 7 stations that exceeded that limit for moderate work. So kind of, in conclusion, the urban areas are exposed to more extremes and higher peaks of ozone concentration, but the rural areas are exposed to more consistent levels. So, you know, it's kind of unknown kind of which is worse, whether constant, more consistent exposure is worse for the respiratory system, or if the higher peaks are worse. But one thing that it could conclude is that ozone pollution is a serious problem in Maryland. And again, this report only focuses on the one source of pollution in ozone. It would be interesting to do this analysis with the other pollutants such as carbon monoxide, sulfur dioxide, nitrous oxides, and particulates. But definitely ozone is a serious problem in the state. So, that's the end of the presentation. Here are the references that were used for the presentation as well as the paper. Okay, thank you, and I'm done.